Hi everyone, welcome back. Today we will be discussing about local replication technologies from the subject storage area network. Introduction to local replication technologies. Local replications are used to create and manage copies of data within the same storage system or infrastructure. These technologies help in data protection, disaster recovery, and data availability. There are various types of local replication technologies such as snapshot, clones, and mirroring. This involves two of them, that is host-based replication and storage array based local replication. In host base we have LVM based mirroring and file system snapshots, and second one we have full volume mirroring and pointer based full volume replication and pointer based virtual replications. LVM-based remote replications. It is a technique used to create the replicas of the data or information asset at remote cities. These replica it serves as a backup mechanism, helping organizations mitigate the risk associated with a regionally driven outages due to a natural disasters or other disrupts. Modes of replication it includes two. One is a synchronous replication and another one is a asynchronous. Coming to synchronous replication, it writes must be committed to both the source and the target. That source that is a primary state and the target is a remote site before acknowledging the write complete to the host. This ensures data consistency but may introduce latency due to waiting for acknowledgements. Asynchronous replication. In this mode, writers are acknowledged to the host before being committed to the target. While it reduces the latency, there might be a slight data lag between the source and the target. So here the diagram will clearly shows you about the asynchronous replication and synchronous replication. In asynchronous replication there is a slight lag and the from the master to the slave, and in synchronous replication there is no lag takes place. Snapshot replication. Snapshot replication captures the state of the storage system at a specific point in time. Snapshots provide a quick and the efficient way to create a point-in-time copies of the data. Users can retrieve back to the snapshots if needed to recover from the data corruption or accidental deletion. Storage array-based local replication. In the storage array-based replication, the storage system operation environment performs the replication process. Unlike server-based replication, server resources such as the CPU and the memory are not used in the replication process. Consequently, the server running multiple VMs, that is a virtual machines, is not burdened by the replication operations. Storage-based system replications support both local and remote replication. In this, we have the full volume replication. In full volume replication, that provides the ability to create a fully populated point-in-time copies of the LUNs within a storage system. Within the replication system, a session is started and initial synchronization is performed between the source and the LUN and the replica, that is the clone. Synchronization is a process of copying the data from the source to the clone. During the synchronization process, the replica is not available for any server access. Once the synchronization is completed, the replica is exactly same as that source of LUN. This replica can be detached from the source LUN and it can made it available to the other server or business operations. Subsequently, synchronization involves only a copy of any data that has changed on the server LUN since the previous synchronization. Pointer-based virtual replication. In pointer-based virtual replication, that is also referred to as the storage system-based snapshot, is a space-optimal solution where compared to the full volume replica. At the time of replication, session activation, the target contains the pointer to the location of the data on the source. The snapshot does not contain data at any time. Therefore, the snapshot is known as a virtual replica. Snapshots is immediately accessible after the replication session activation. This replication method either uses the copy on first write, also called as COFM, or redirect on write mechanism. Multiple snapshots can be created from the same source LUN for the various business requirements. Considerations for implementing local replication technologies. First, you have to understand the data protection requirements and recovery the objectives of the organization. Evaluate the performance impact of replications technologies on the storage infrastructure. Ensure compatibility with the existing hardware, software, and network infrastructure as a seamless integration. Here are some pros and cons of the different data replication architecture. First one, the array. It involves the pros are offloaded performance overloaded from the server, OS, and the file system, and you mature of the most of the mature of the replication options. Then cons is only work between a single vendor storage, only the replication data at the block level. In the host, you supported for the internal and the external storage. That is an advantage. You can access the server or the storage infrastructure. Production Product support asynchronous or the synchronous application. The disadvantages, like it is required license on the source and target server. Most of the must be complete with a server OS. In the network architecture, it is offloads the performance overhead from the server OS and the file system. Authentication, support synchronous and the asynchronous. Cons includes may require installation of the host agent, may need to pass all the input or the output traffic through the appliance, may need to recognize the storage network to pass the traffic. Then last one, that is a hyper server. It is typically specially designed for virtual machines. Ability to standard or single replications tool, lower cost, seamless management. Then the disadvantages includes consumption of the CPU and the network processing, may have higher latency than the storage replications, may be less efficient when compared to the other replication architecture. Best practices for the local replication technologies. So regular tests and valid replication process to ensure data consistency and integrity. Implement monitoring and altering the mechanism to track the replication status and address issues promptly. Document replication configurations, procedures, and recovery process for each reference and troubleshooting. Conclusion. Local replications technologies play a crucial role in the data protection, disaster recovery, and data availability. By leveraging the snapshot replication, cloning technology, and mirroring, organizations can enhance their data management capabilities. Implementing these best practices and considering the key factors are the essentials for successful deployment of the local replication technologies. That's all about the topic local replication technologies. Please do like, share, and subscribe.